Hello, friends and followers. Well, now that the Central Electronics 100V is working, I can go over how the controls work for people that might be getting one of these in the future and want to save it from the junk pile and are curious how to run the radio. So this is my little tutorial on how to run the radio. Let's go over the controls. There is an emission control here, whereas you will set the emission of the radio. And I'm trying to get some good lighting here. There we go. So you can go with FSK for teletype, CW for, well, CW, pulse modulation, or sorry, phase modulation, which I think is like FM, standard AM, which I love, upper sideband with carrier, lower sideband with carrier. I'm not sure why people would want to use those, but they're there. Double sideband, which is weird, but it's there. The standard upper sideband and lower sideband that we're all used to. And a null function to make sure there's no carrier in the balance modulator, so the sideband will work correctly. This light here is a limiter. Basically, it says when there's enough audio going in and maybe too much, it'll come on. So right now I'm feeding audio into the radio, into the transmitter. And if I turn this knob, which is the audio input knob sensitivity, and I raise it up too high, you'll see it'll start to limit. It's saying, look, I have enough audio. And you can pump audio into this thing when it's in standby. It doesn't matter. It'll still take the audio and deal with it. This knob here is your carrier level, and it only affects operation in voice mode here or carrier. And these modes really are for tuning the radio to a receiver or transmitting in a, not even a tune mode. It's like a very light transmitting mode, and it's irrespective of any of these controls. So you can put the transmitter, say, in carrier mode, and then you'll see a carrier pop up on a receiver, like that carrier right there. And when I vary this carrier level, this will change the bias to the driver tube and to the finals. So you want to put this meter into watts mode. And now we're looking at watts input to the final. And when I increase this carrier level, you'll see the watts creep up, meaning the finals are getting less bias and they're conducting. So this is not an indication of RF output. It's simply how much power the finals are consuming, with the bias going down from, say, negative 100 or so to minus 40 and below. All right, so that's how that works. That's carrier mode. When you go to voice mode here, you can then use this for tuning up or listening on a receiver with any mode available here. So it will basically transmit in whatever mode you select in this tune mode. So that's how that works. And when, say, I go here to CW mode, and well, if I go to carrier, it'll put a carrier out in any mode it wants. Well, any mode it can. It really is CW mode, and then it will ignore the audio. So carrier mode will always transmit a carrier. When you crank this up, you'll see the power will go up. You might see a little bit of power in the watt meter. There's also an amps, so that's antenna amps basically. So if you go to amps here and you crank this way up, you might see a little bit of power coming out. Yeah, there we go. So it's showing there is some power out to the antenna that way. Dummy load here, and you'll see there's some power out to the dummy load. So that's how you work this calibrate level. And then with voice, you can go here and use voice to tune yourself up, and just simply increase this until you can hear yourself on the receiver, and that's how you do it. All right, and this knob here really is self-explanatory. It's simply for tuning yourself on the band. This VFO is extremely accurate. It's a really great VFO. In fact, I think the VFO is one of the best parts of the radio. When you change your band, it changes the scale here. So if I go, say, to 80 meters, the scale will change to 80 meter scale. That is undetermined. It's an X scale. There's 10 meter band scale, 15 meter band scale, 20 meter band scale, and back to 40. That's how that works. You can look at line voltage here. When you go to line, you'll see at the very top, there's a little line indicator there. It's in red. It says line L and H. I keep it at L, and even then I'm probably over voltage because the power supply in this thing is a 200V power supply I installed, and it doesn't work quite right. It's probably going to blow someday, but for now it's working. What else can I tell you? Mismatch will come on when the antenna is mismatched. A relay in here will vibrate and make noise and chatter and turn off the screen current to the finals. When the screen gets too high, that relay will chatter. So you can go off here, standby. This will do VOX. I don't ever use VOX. I don't even know if VOX works. I don't even have a microphone on this radio yet. Push to talk for a mic you connect in the back, and manual will put you in transmit no matter what. So it'll go in full power. So let's now go over how to raise and lower the power. Behind these trap doors are some settings. This one's very simple. This top knob is your power output. So this will vary an 8 megahertz RF input to the mixer. So this knob will vary your power output to the antenna, but it will not affect the power input to the final, which I find is odd, but that's how it works. So even if you're transmitting and you have this thing on watts, this watts is input power to the final. It's not watts of RF you're generating. So that's a distinction. This control here is what? I never have used it. Monitor. I have no idea what this does. I think this is for, I don't know. Haven't played with it yet. This one here is VFO versus crystal. This is where you can put a crystal in to have crystal operation. So that takes care of all that. Behind this trap door on the left, bunch of controls. Okay, this is basically your CW power input. So if this control is down, you won't get CW. If your output control is down, you won't get CW. This has to be up. I'll turn it up all the way, and this one has to be up a reasonable level. That way you can set your CW output power and your AM level independently, and your output also independently. This output though, control here is a master. This is master output, and these are subservient to that output. All right, and what's left? We have a bunch of VOX stuff. I never use VOX, so I don't care about VOX, but this control in the middle is for your audio input, so this will affect mic gain, and it'll affect AF input from the back. Right now, and on all the videos, I've been using AF input from a Drake R4B for testing. And that works quite well. You can throw 8 ohm speaker input into this thing and it works just like the nuts. So what else is here? VOX, that's your VOX sensitivity. Like I say, I don't use VOX yet. What's this other one here? QT. QT basically is, if you have a speaker in the background from your receiver, that's how to quiet the speaker from keying up the mic. Like I said, I don't use VOX. That would take some learning to make that work, and maybe some fixing. Okay, this next control here is a what? Okay, this is your deviation for your FSK. I don't use FSK. I haven't tested this yet. This may or may not work. I guess you can go 100 cycles here up to 900 cycles when you key the FSK input on the back. It'll make the transmitter go that many cycles up, I suppose, or down. And the last control here is a what? This is a, I can't see it. Okay, it's a delay time. So that delay time is when you say go to manual and then you go off, it'll delay. It's sort of like a hang time for CW and for voice operation. and probably VOX too, like a hang time. Handy if you don't want relays to click. And okay, that leaves this control here for CW. This is basically your output power for CW. This is your output power for AM carrier. So this has to be set correctly. The manual says to set it with watts input, but this radio is all fouled up with the power supply being different. So I'm not sure yet how to set this. I'll probably use the scope, which is missing because the scope CRT is blown. So I threw it out. And ordered a new one. Okay, so that leaves these two controls. This is like A channel and B channel for when it mixes these things for sideband mix to get the sideband proper and cancel it out or use addition. So to set that, you can look at your power output on a receiver, or you can go to the null mode here. I'm not sure that one of these is working right, but I don't have much RF coming out right now, so I'm pretty happy with it. But basically, you can turn these, and with one hand it's going to be tough, but this is spring-loaded for null. And you can see on the meter right now, I don't have any appreciable carrier. But the way this is calibrated is that you have a scale on the bottom which talks about suppression. It's called carrier suppression, and I'm trying to get a good there carrier suppression, so you can see where it's like -50, -40, -30. Anyway, this one's working quite well because I've replaced diodes in the balance modulator and little capacitors in the balance modulator and all sorts of things that that Dominic Tusa recommends. So anyway, if you want to work with this null, you just want to set it for the greatest dV, which means no meter movement. So just move this to null and rotate these two knobs for the meter to have no movement, and you're all set. So let me try and demo that with one hand. Let's get everything in here. Okay, you can see the meter there. Just remember that low is good. And if I go to null here mode, and now it's a null, and if I turn this knob, you'll see it'll rise. Watch this. So that's bad. You want to turn it till it goes all the way down, and that's all you do. You just get it down all the way. And if your radio works properly, you can do that. This other one doesn't do much. It is probably needing work, but it will null it if I'm down in one position, and that's it. So you set it for null like that. You can also watch a receiver and null it that way. So that way of doing it would be, you would go to USB mode here, or LSB, and you would go to voice mode like this, and you'll see there's some input to the final there in watts, and you would then increase this. Okay, you can see I got some signal there, and I'll turn the audio down. So now I have no input to my USB. There should be no signal coming out if you're balanced. However, if you're unbalanced, and I'll unbalance this thing, you'll see a signal coming out. So I'll unbalance it. There's my carrier. I'm gonna balance it until the carrier is gone. And that's it. If I keep turning, the carrier pops back. So this setting is typical in balance modulators and all sorts of radios, tempo ones, even in Drake's, or TR4s and T4X, B and C, and even the Yaesu FT102. This control exists in some form somewhere. They all have a balance control, and this one's the same way. You can turn that until it's nothing. Here's some carrier, and turn it for no carrier. So that is my rundown on the rig. I understand you can get eSSB or very wide SSB by pulling out the audio limiter module. I think it's that one. Pull that one out. You can jump pins 2 and 5, and this thing will have superb audio, very wide audio. I was working on that module. It works. I gotta put the case back on it, but it's a working module. All right, so that is my rundown on the radio. This is a 200V transformer that I got from Nick, or from Dominic Tusa from CE Multiphase, and he did a great job sending it to me. I have Just made a basic bridge rectifier with 4 3 kb diodes in here, and I pulled out the other 2 capacitors. I had one hell of a time putting in these capacitors to replicate the 200V power supply. I haven't replicated all of it. It's still got maybe some 100V-esque in it. The power supply doesn't work right. When this transformer has 123, 125 volts, I get 845 volts on the secondaries. That's way too much power for these tubes, these capacitors. I keep thinking these are gonna blow because I'm right smack at the edge on this thing. And the rest of the tubes take 340 volts B+. I'm probably running them at 400 something volts. So yeah, I got a little Chinese auto transformer here, keeping the voltage down. So anyway, yeah, my line voltage is on the low side, and I'm never going to take it up here. It'll probably blow the radio up. So I do have power supply problems. I can't really figure out yet what to do with it, but the radio now is working, so it may never get fixed. I'm going to try and fix the scope here and maybe some other little problems. And maybe somebody will come along and tell me what's wrong with the power supply. That would be nice, as I've battled with it. I'm not great at power supplies. I don't like them. They're dangerous and all that. So, but they're a necessary part of refurbishing boat anchors. So I know enough to replace capacitors and follow diagrams on schematics. I'm not much at making my own power supply from scratch, but I can follow a recipe like anybody else can. So that's about it. I hope you enjoyed the video. It's probably been a month of work to fix this thing, maybe a month and a half. When I got it, it was damaged from shipping and it didn't work. Somebody had pulled out many capacitors and sent me a bag of capacitors. So this thing was a basket case when I got it, and it's now working. It's been transmitting a long time too, crud. Okay, there we go. Let's take it off transmit. So, oh, I'm online. Yeah, I still don't know the video that much. There we go, there we go. Okay, that's my video. I hope you enjoyed it. Let's try it one last time, make sure this darn thing's still working here. Let me go to, okay, we're on USB. The radio's been running a long time here. Let's key it up. Go to voice, we got carrier, and give it some audio. And there's some audio. Looks like LSB to me. So lower sideband means you're starting at the carrier and you're going down. That's lower sideband, and it looks good. Go to upper. It'll be the opposite. You'll see it going up. That's how it should look. Double sideband means you have 2 of those either side. So that's how that should look, I suppose. And lower sideband carrier has a carrier in the middle there, and lower sideband. Upper sideband carrier. Upper sideband carrier. We all know what AM does. There's AM, and that looks like reasonable AM, I suppose. You can vary the AM here with this level to increase the carrier. And your power has to also be up, so we'll give it some power here. And there's my AM. You can vary the power up and down to get it proper. And if the scope was here, I think that would be great. I ordered a new tube for it. The tube in here was open filament, so it got trashed in the trash can. Okay, this has been a big job for me. I've had all sorts of junk here taken apart. The room's a mess. Everybody's mad at me. This has been an obsession to make this thing work, and I gotta get this room cleaned up. I had to buy a capacitor meter to fix the PS2. I had to buy this thing to not blow the radio with low power. The room is a complete mess. The scope's out. There's radios here that needs fixed. There's a Omni 5 here, Omni 6. I've been ignoring those for a month because my obsession has been to fix this central electronics. All this junk is sitting here. It's gonna get put back away. I don't have a really great way to organize parts, and when I want to find a part, I gotta pull apart everything to find it. So, big mess. There's a nice Heathkit amplifier that works fine. I restored the Drake R4B, I guess a few weeks ago. It's been working great. Antenna tuner, which is very useful. There's a Henry over there, which I have for sale. Why am I selling it? I don't know. I just stuck it up for sale on eBay. And I have a Drake L4 amplifier on the way, but I'm finding I'm running out of time to fix things. Anyway, this thing's still transmitting. The finals in this thing run awful hot. There's a fan in here running. Wow, they're really toasty. They're really, really hot. I'm not sure if they're supposed to run that hot or not. There's also a fan that goes here. Since this transformer is a different size than what was in here, the fan bracket goes here, but I gotta make it fit and get the fan on, and maybe put this thing back in its cabinet sometime when it's working. But I think for the time I'm done with this thing, I could probably tweak it to get my power out in 80 meters and in on 15. And the 20 meter Joe Bachelor broadband coil is toast. It looks like it burned up, so maybe Nicholas can, Nicholas is not his name, Dominic can help me figure that thing out sometime when he has time or not. And that's about it. So if you have one of these, I've probably posted 20 videos on all my travails with it. I hope it helps you. It sure is a pretty radio. It's a very interesting radio. It's a piece of history. And I think to keep it working, you would be honoring Joe Bachelor and mostly Wes Xiang. And we still got one of the crew alive with us. And of course, his name is Dominic Tusa. So that's my little story in making living history work. Have a great day, and thanks for watching.